Next is the empirical formula and molecular formula. We know what is molecular mass. That's the sum of atomic masses present in a molecule. Atoms combine together to form molecules, and sum of these atomic masses in a molecule is considered as molecular mass. And that formula which represent the atoms present in that particular molecule is called molecular formula. For example, water. We know the molecular formula of water, H2O, 2 hydrogen and 1 oxygen. And for carbon dioxide is CO2. For another molecule, glucose, C6H12O6. Okay, this is about the molecular formula which contain the exact number of atoms present. And here in glucose, each molecule of glucose contains 6 carbon atoms, 12 hydrogen atoms, again 6 oxygen atoms. That's the exact number. And these exact number which represent what? Yes, or the molecular formula represent the exact number of the atom. That's the molecular formula. And the simplest form of this molecular formula is termed as empirical formula. For example, we can divide the base 6, 12, 6 using 2. And how we get? Yes, C6 by 2, then H12 by 2, O6 by 2. What's the answer we get? Yes, C3, H6, yes, C3, H6, O3. Again, if we simplify, we can write like this, CH2O. This is the simplest term. Okay, here we can divide by 6. 6 is common for carbon, hydrogen, oxygen. So, if we take 6 out, we get CH2O. This is the empirical formula. Simplest form of molecular formula is called what? Empirical formula. Or we can define simple whole number ratio of the elements present. Okay, simple whole number ratios of the element present, that is called what? Empirical formula. And what is molecular formula? It is the exact number of different atoms. The exact number of different atoms. Okay, and next our duty is to study how to derive the empirical formula and molecular formula by knowing the percentage composition and molar mass. If the percentage composition of a particular molecule is given, we know what is percentage composition. Percentage of all the atom present, that is a percentage composition. We have what? The percentage composition of all the atoms present in that molecule, and what are the atoms then, and the molecular mass of that particular compound formed. We can easily find the molecular formula as well as empirical formula. But there are so many steps in order to find this empirical formula and molecular formula. Let's do with an example. Let's discuss a question in order to find the empirical formula and molecular formula. The question is this: a compound contains 4.07% hydrogen, 24.27% carbon and 71.65% chlorine. Its molar mass is 98.96 gram. What are the empirical formula and molecular formula? And in this question, the percentage composition of 3 different elements are given: carbon, hydrogen, chlorine. The percentage are given. First of all, we want to know what's the symbol in order to represent these elements. Carbon, we know it's C, hydrogen H, chlorine Cl. Okay, and in order to make easy, we draw a table like this. And the first column, element, the elements present or elements. Okay, elements present in that. And next one, mass in gram. Here percentage, the mass is given in percentage. There is a mass percentage, and we consider total as 100%. Okay, or 100 gram. Out of 100 gram, 4.07 gram hydrogen, 24.27 gram carbon, 71.65 gram chlorine. Okay, we consider in that sense. So, mass in gram, that's the next column. And next one, atomic mass. It's very important, this column, we want to know this one. Atomic mass of at least first 20 elements. Then number of moles. The next column, number of moles. How we find the number of moles? How we find the number of moles? The number, for example, 160 gram of oxygen. How many moles present in 160 gram of oxygen? In 160 gram of oxygen, how many moles are there? For that, we find given mass. 160 is the given mass. 160 divided by mass of oxygen, again 16 equal to 10. So, in order to find the number of moles, what we do? Yes, given mass divided by gram atomic mass, or simply given mass divided by atomic mass of that element. That's where we find the number of moles. So, our fourth column is number of moles, and next one, simple whole number ratio. That's the column we will discuss later. What's it? First, write the simples of the element downwards. Which are the elements given in the question? First, write. Okay, here hydrogen is given, carbon is given, chlorine is given. We write. The next one, mass in gram. That means here the percentage. Okay, we consider the percentage as what? Gram. So, hydrogen it is 4.07. Then carbon it is 24.27. Then chlorine it is 71.65. That's all. Then atomic mass. Hydrogen we know atomic mass 1. Carbon 12. Chlorine 35.5. Okay. And the next one, number of moles. Here, if we want to find the number of moles present in 4.07 gram hydrogen, what we do? Yes, the given mass is 4.07. The given mass divided by the atomic mass of hydrogen. So, given mass is 4.07 divided by 1, we get 4.07. Okay. Then, for carbon, in 24.27 gram, we want to find the number of moles present. So, the given mass is 24.27 divided by atomic mass 12. We get 2.02. Okay. Then chlorine, 71.65 gram chlorine contain how much number of moles? For that, the given mass 71.65 divided by 35.5, that's the atomic mass of chlorine. We get 2.018. I think it's clear. First, write the elements by simples. Then, mass in gram, that's already the percentage we write as. Then, atomic mass of that element. Then, number of moles. Number of moles. How we find the number of moles? Yes, given mass divided by atomic mass. And the next one is very important. The last column is very important. Simple whole number ratio. And here we get some point 4.07, 2.022, 2.018. The number of moles. Out of these number of moles, which one is the smallest digit? Yes, 2.018. Then using that number 2.018, divide all other number of moles. That means this is the smallest digit, 2.018. This number divided by 2.018, then this one divided by 2.018. Okay, so 4.07 divided by this small digit 2.018. We get approximately 2. Not 2, 2.0 something. And here 2.022 divided by what? 2.018. We get 1.00. Then 2.018 divided by itself. 2.018 we get 1. And this is a simple whole number ratio. Take it out. And here, which are the elements present? Yes, hydrogen is there. Then, carbon is there. Chlorine is there. Okay, hydrogen is there. Carbon is there. Chlorine is there. And hydrogen, the whole number ratio. What's the ratio for hydrogen? Yes, we get 2. Then, for carbon, we get 1. Then for chlorine we get again 1. Okay. So multiply the base with this H2Cl. Okay. Based on electronegativity we write like this Cl H2Cl. This is actually the empirical formula of that particular compound. Okay, the simplest whole number ratio, that's the empirical formula. This is the empirical formula. Our next task is to find the molecular formula. For that, first find empirical formula mass. This one is the empirical formula, or we can write as H2CCl. Both are correct. And here, which are the atoms present? Hydrogen, carbon, chlorine. Hydrogen, 2 hydrogen atoms. So, atomic mass 2. Then carbon, 12. Chlorine, 35.5. The empirical formula mass is same way as we calculate the molecular formula mass. Okay, or the molecular mass. We get what? 49.5. 49.5 is the empirical formula mass. And next one, we want to find the ratio between the molecular mass and empirical formula mass. And we put as N. N is equal to molecular mass divided by empirical formula mass. Empirical formula that we derived. And the mass of that empirical formula is the empirical formula mass. That's the mass of CH2Cl. And molecular formula is what we given in the question, 98.96. So, the molecular mass 98.96 divided by empirical formula mass, that's what empirical formula mass is calculated as 49.5. So 98.96 divided by 49.5, we get 1.99, and we round off and take it's 2. Okay, this is N. Then using this 2 or multiply this 2 with this one, this empirical formula, and we get what? CH2Cl into 2. All the base are multiplied with 2, we get C2H4Cl2. C2H4Cl2 or H4C2Cl2, both are correct. Clear? This way we can deduce molecular formula and empirical formula. I think it's clear. The table is important. Elements, then mass in gram, atomic mass, number of moles. How we find the number of moles? Yes, given mass divided by gram atomic mass, or given mass by atomic mass. And next one, simple whole number ratio. First write the elements, then the mass of that element, given mass of the element, then correct atomic mass of that element, then number of moles. The next one, simple whole number ratio. And using this simple whole number ratio, we can deduce the empirical formula, and we get the empirical formula like this. And next task is to find the empirical formula mass, and empirical formula mass we find as 49.5. And next task is a ratio between the molecular mass and empirical formula mass, and we put as N. We find the N value, then multiply the N value with the empirical formula. We get the molecular formula. One more question from that area. Determine the empirical formula with given percentage, and percentage composition is given, and our duty is to find the empirical formula. Okay, and the first one, 40.0% carbon, 6.0% hydrogen, 53.3% oxygen. That's the question. Once more, determine the empirical formula with given percentage. 40.0% carbon, 6.7% hydrogen, 53.3% oxygen. First of all, draw the table neatly with the columns elements, then mass in gram, atomic mass, number of moles, simple whole number ratio. Okay. First one, elements. Write the elements. Which are the elements? As carbon, hydrogen, oxygen. Then downward write the elements. Carbon, hydrogen, oxygen. Then mass in gram. That's the given mass percentage. Carbon 40 as per the question. Hydrogen 6.7. Oxygen 53.3. Then atomic mass. What's the atomic mass of carbon? Yes, 12. Hydrogen, it's 1. Oxygen 16. Then find the number of moles. How we find the number of moles? Yes, given mass by gram atomic mass, or given mass by atomic mass. And here the given mass of carbon 40 divided by 12 is 3.33. And next one, for hydrogen, given mass 6.7 and atomic mass 1. So 6.7 by 1, it's 6.7. And next one, oxygen, 53.3 by 16, given mass by atomic mass. Again 3.33, and which one is the smallest digit out of these? Yes, 3.33 is the smallest digit. So divide all the numbers, all the number of moles using that 3.33. The first one 3.33 by 3.33, it's 1. 6.7 by 3.33, it's 2.01. Then again 3.33 by 3.33, it's 1. Okay, then write the elements carbon, hydrogen, oxygen, and the ratio 1:2, 2:1. Then by writing the ratios on the base, we get CH2O. That is the compound with empirical formula CH2O contain 40.0% carbon, 6.7% hydrogen, 53.3% oxygen. Okay, that's empirical formula. What's the empirical formula? Yes, it's the simplest whole number ratio. And what's molecular formula? Yes, it's the sum of atomic masses or the exact whole number ratio. That's the molecular formula. And to find the empirical formula and molecular formula, what we do? Yes, first we write the elements. Then the given percentage is written as what? Given mass. The next one, yes, atomic mass. The next column, atomic mass. And next one, yes, number of moles. How we find the number of moles? Yes, given mass by atomic mass. And last one, simple whole number ratio. And we get the simple whole number ratio and multiply the bases with the element CHO. 1:2, 2:1. We get CH2O.